Hello, this is Mr. Rasmussen with Algebra 2 lesson 96. And in this lesson, the first part, we jump back into our variation problems where we have it either related directly or inversely. And in this case, we have three parties involved, so it can be jointly related or you see the other option here, where one could be inversely related and the other directly related. So let's go back and review some things here. First of all, when you have a direct relation, in other words, if one goes up, the other one also goes up. For finding your constant in a two-step problem, it would look this way, where you're multiplied, or in a ratio setup, it would look this way, where all the ones are across the top and the twos are on the bottom. This one here is the inverse proportion. If one goes up, the other one's going to go down. And we can see the setup here through finding a constant and then doing it as two steps. Or this one here, you can see the second fraction is flipped to show if one goes up, the other one will go down and vice versa. Today, we look at this here. If it says very jointly, we have three things here. We've got a P, an A, and an R. And if it says varies jointly directly related, then we can see here that all the ones are across the top and all the twos are across the bottom. See, it just adds the second one in the same fashion. If it says that it's inversely proportioned and varies jointly, then that means when one goes up, both of these are going to go down, or if this one goes down, both of these are going to go up, and we can see the second fraction is flipped, the two on top. All right, then the other scenario is, and they give girls, boys, and teachers. I'm talking about if girls is inversely proportional with boys, then you see that goes on the bottom there inside of the two-step problem with a constant. And then directly related to the teachers go on top there. You can see the setup here. Girls are inversely proportional with the boys, so we start with the girls. Notice the boys' equation is flipped, the 2 is on top, but directly related to the teachers 1 is on top too. So let's work through example number 1, and let's see how we do this. All right, we got the number of girls varies inversely as the number of boys and directly as the number of teachers. So we're going to be using these equations here, and we'll plug in some numbers. So it says when there were 50 girls, there were 20 teachers and 10 boys. Okay, so I'm going to use this first equation and solve it both ways like they do in the book there. So they say that there's 50 girls, and put our constant in there, and then it means there's 20 teachers and 10 boys. Okay, so I need to solve this to get my constant in this first way here. And to do so, I'm going to leave my constant there and then inversely, actually 20 divided by 10 is 2. And so I'm just going to put a 2 here and my constant is going to be 25. Okay, so I'm going to put that back into my equation. So put a 25 there instead of my k and put in my new inputs. It says how many boys were there. Okay, so I don't know what the boys are. So let's put the boys in there as a variable. When there were 10 girls, so 10 over here, and 100 teachers. Okay, so the girls' number went down, which means the boys' number has to go up. There's going to be more than 10 boys. That's a lot of teachers, huh? Okay. So let's cross multiply here to get the b into our numerator. So b is going to come up, 10 is going to come down. We can cancel 1 0 with that. So 10 times 25, we have 250 boys is our answer, since the girls went down, the boys went up, and it's also related to the teachers. Okay, let's look at how we do it through the ratio setup here. The first girl's number is 50, the second girl's number is 10, equals the second number, inverse with the second boy's number is what we don't know the answer to, so we'll keep that like that. The first boy's number was 10, so put that there. And then the first teacher number was 20, and the second teacher number was 100. So we just plug all the values in there in the right spots and multiply out. These two zeros can cancel, and then this 2 is going to go down, so it gives me 20 on the bottom. It's equal to my boys top. These two, 10 times 10 is 100. That's going to come up, so it looks like we have 5,000 there. These two zeros can cancel. 500 divided by 2 is our answer of 250 again. Okay, so that is example problem 1. Go ahead and look at example problem 2, and you can walk yourself through that. Okay, the second part of today's lesson is similar to yesterday, but we're going to look at what happens when you do this, but you can't factor it into two binomials. So we start out the same, and we get x is equal to 6 over y, and then we substitute that in. So 6 over y minus 2y is equal to 3. Divide each term by y to cancel it in our denominator. So we get 6 minus 2y squared equals 3y. This is looking very similar to yesterday. We're going to divide everything by a -1 to flip our signs. And then we're going to rearrange. So 2x squared, bring this over by adding it to both sides. 3y, and then this one's already over here, but the sign flips, -6. Alright, so this looks similar to yesterday, except for the fact that we can't divide it by 2 to get this first term to be a 1. And if we tried to factor it, it's not going to work out. So we can't factor that into the two binomials like we did in the previous lesson. So what we're going to do, we're going to use the quadratic equation. Okay, so quadratic equation, plug in some values in. All right, so we've got -b, so -3 plus or minus the square root of, and then we have b squared, so that would be 9. We'll simplify that first. -4, plug in our a value of 2, plug in our c value of -6. All that is over top of 2 times a, which is 4. And I'll just look at the book there. If we solve this through, this is going to be our answer for y. So y is equal to -3/4 plus or minus square root of 57 over 4. Okay, so that's our y value. So let's start an answer down here. We'll go -3/4 plus square root of 57 over 4. And start another answer of -3/4 minus square root of 57 over 4. All right, so there's both of our y values, and now we need to find our x values. Okay, so we used quadratic equation to solve that, and I'll work fully through that on the practice problem. I'm just looking at the book for this one. Okay, so now we got to take this, and we're going to plug it back into, this is y, we're going to plug it back into this equation right here. So if we rearrange this equation and get x is equal to, and move this over, we get 2y plus 3. Okay? So let's try here. X is equal to 2, and then y, we've got to substitute this in here. -3/4, we'll use the first equation, plus square root of 57 over 4, and then plus 3. As I take this equation and simply substitute in for y. Alright, now to do this, we're going to multiply the 2 into both of these terms. So 2 times 3, I get -6 over 4. Let's immediately, let's immediately reduce that to 3 over 2. And then plus 2 square root of 57 over 4. There has been parentheses have been removed. Then we've got this 3 over 1 sitting here, and that could be added to this because it's like terms. So since that one has a 2 in the denominator, let's change this one to a 2, which makes a top of 6. So if we add -3 and 6, we get a positive 3. I'll start writing it down here as my answer. We get a positive 3 over 2, and then plus, and then this 2 and the 4 can reduce to 1/2, so 57 over 2. All right, and that is the answer you see there in the book. So as we come, so we got one answer here. Then we come back, and if we look at this problem here, the only thing that's going to change is putting this one in, is that this sign here is now going to be a negative, which means it's going to be a negative there, but otherwise it's going to be the same answer. And so we'll write that out as 2/3 minus square root of 57 over 2. And that's the only thing that's going to change for that second answer there. All right, and that is example 3. All right, let's work through some practice problems here. Practice problem A, they give us that tough one first. So practice A, let's get into that and see how we do. All right, so we have x minus 3y equals 5, and then we have our xy equals 3. All right, so we're going to rearrange that first equation. X is going to be equal to 3y. Let's put it in. So x minus 3 times 3y is equal to 5. Oh, I did that wrong. That's why I was looking funny. Let's try that again. I put in for x, I put it in for y. All right, so 3y minus 3y equals 5. There we go. Now we're going to multiply everything by y to be able to cancel it in that first term. So we get 3 minus 3y squared equals 5y. Let's multiply everything by a negative 1, be able to cancel that out. So negative there, positive, and a negative. Let's put the 3y squared in the front. Add 5y to both sides, get it over there, and then minus 3 equals 0. Okay, so I've got my a value, my b value, and my c value. I look to see if I can factor it, but I'm not going to be able to. So that means we go to our quadratic equation. So my minus b value, which is going to be negative 5, plus or minus the square root of, then 5 squared minus 4, parentheses 3, parentheses negative 3, and then all on top of 2 times my a value, which is 6. Okay, if I work through this one here, 5 squared is 25 minus negative 4 times 3 is negative 12. Negative 12 times 3 is a positive 36. So if I add those together, I'm doing that inside here. That's supposed to be inside here. All right, if I add those together, it looks like I get 61. So now I have negative 5 plus or minus the square root of 61, and that's over 6 here, and that's over 6 there. Okay, so there's my answer for my y values. Let's start my answer down here. So minus 5, 6 plus square root of 61 over 6, and then minus 5, 6 minus square root of 61 over 6. All right, so those are my two y values. And remember, we got to plug it back in to get the x value. So let's rearrange this equation. It's going to be x is equal to 3y plus 5. And so let's plug it in there. X is equal to 3 parentheses, substitution, 5, 6. And I'll use this one first, plus square root of 61 over 6, and then plus 5 at the end there. Okay, so if I multiply this in here, I'm going to get negative 15 over 6 plus 3 square root of 61 over 6 plus 5. Okay, let's see here. This one can be reduced, and this one can be reduced and we get 1/2 there. This one can be reduced. If I go 3 into here, I get a 2. 3 into here, give me a 5. Okay, so I get negative 5 halves. But I still got this guy sitting over here. So if I change him to a 2, the top becomes a 10. So negative 5 plus 10, I'll start writing my answer in. That's going to be a positive 5. So 5 halves plus the square root of 61 over 2 is my x value from the first one. And then notice that if I put this value in, the only thing it changes is it flips that sign there. So 5 halves minus square root of 61 over 2 is my answer for x value for my second part there. Okay, and that looks correct. You just see the consistency there. There's my answer for practice problem A. All right, practice problem B is my first part of my lesson there. So let's look at this to see which equation we're going to use. I'm going to use the ratio because I think you would use that one as well. So the number of elk varied inversely as the number of deer and directly as the number of antelope. All right, so let's set up the first part here just to see what's going on. So we got elk number 1, elk number 2 is equal to, and then inversely proportional with deer. So deer 2 goes on top and deer 1 on the bottom, and then directly proportional with antelope. So antelope would look this way. Okay, let's plug in our numbers. Our first elk number is 75. Our first deer number, and that, remember, the first deer number goes on the bottom, is 85, and my first antelope is 15. And so then how many deer were they? So deer 2, that's my variable, don't know what that is, when there's 20 elk and 30 antelope. Okay, there it is. We are all set up, and I'm going to cancel some things here. 15 over 13 is the same as 1/2, so we'll do that. My variable is already on the top, so that one doesn't have to change. But nope, we're good. So on the top here, cross multiply, we're going to stick it over here. We got an 85 coming up, and then we got a 2 coming up. So I'll grab the calculator here. 2 times 85 times 75 divided by 20 equals, and I get an answer of 637.5. That does not sound, I would like it to be a whole number. Well, guess what? Number of deer is equal to 637.5, and looking at the book there, that is correct. It's not a whole number. It's got a decimal part. Okay, hope that works well for you. Go ahead and text me if you need some assistance, and have a great day.